Hello and welcome back. Today I am going to discuss the part 2 of .NET Core 3 Preview 1. So in the last lecture we have covered some aspects of the first preview of .NET Core 3 because it was very big, so I decided to divide it into at least two parts. So this is the part 2. So the disclaimer, this part tries to explain some more features announced in .NET Core 3 Preview 1, which I found to be interesting and important from a .NET developer's perspective. But be aware, these discussions do not cover all the changes announced in detail and available at the link given again below. Right. So this is based on this devblogs.microsoft.com, and I will put it in the description. Right, so let's get going and see what are the remaining features of Preview 1. So local .NET tools. A local tool scenario is added to the .NET Core tools. A particular location on disk can now be associated with a set of local tools and their versions. And local tools rely on a manifest file named .NET-tools.json. Microsoft suggests supplying the tool manifest file at the root of the repository. If you clone a repo that contains local tools, you need to run the following command: .NET tool restore. After restoring, you can call a local tool with .NET tool run and then the tool command name. And when a local tool is called, the .NET searches for a manifest of the directory structure, and when the tool manifest is found, it is searched for the requested tool. Now, if the tool is found, it includes the information needed to find the tool in the NuGet global packages solution. Correct version of the tool from the tool manifest file was placed in the cache on restore. Now, if the tool is found in the manifest but not the cache, the user receives an error. Now, to add local tools to a directory, you need to first create the tool manifest file. For Preview 1, you must create the file names .NET-tools.json with the following contents. So version 1 is root, true, tools, a pair of curly braces. Okay, so this is the minimum content in the manifest file, tool manifest file, which is also named as .NET-tools.json. Once the manifest is created, you can add local tools to it using .NET tool install tool package ID. Now this command installs the latest version of the tool unless another version is specified. This version is written into the tool manifest file to allow the correct version of the tool to be called. The tool manifest file is designed to allow hand editing, which you might do to update the required version for working with the repository. Also, to remove a tool from the tool manifest file, just run .NET tool uninstall and with the tool package ID. So here you have made it tool install tool package ID, and just install is replaced by uninstall command. Okay. An example .NET tools.json, that is the tool manifest file, looks like version 1 is root true, tools.NET say, version 214, commands .NET say, T-Rex version 1.03, 1.0.103 T-Rex. So please don't worry about understanding everything in .NET tools.json. This is just for what the changes .NET tools will look like. .NET tools.json will look like. So introducing a fast inbox JSON reader. So one of the other features of the .NET Core 3 Preview 1 is a system.text.json.utf8 JSON reader, which is high performance, low allocation, forward only reader for UTF-8 encoded JSON text, is read from a read-only span. Now, reading through a JSON payload using the new UTF-8 JSON reader is 2 times faster than using the reader from JSON.NET. So JSON.NET is extensively so far used in the Microsoft .NET framework. So now a new UTF-8 JSON Reader has come, which has replaced the conventional JSON.NET. It doesn't allocate until you need to actualize JSON tokens as UTF-16 strings. This new API will include the following components. In preview 1, JSON Reader is just a reader in the preview 1, sequential access, and coming next is JSON Writer. So DOM, random access, POCO serializer, POCO deserializer, plain old code only. POCO means, those who are got some familiarization or idea about entity framework, they would know what is a POCO, plain old code only. In .NET Core 2.1 and 3, Microsoft added new APIs that makes it possible to write JSON APIs that require much less memory. The JSON APIs are based on using span-t, a special class span-t, and UTF-8 strings, and better serve the needs of high throughput applications like Kestrel, ASP.NET Core Web Server. Okay. Now ranges and indices. Now Microsoft has added a type index which can be used for indexing. This is in C#. So these features are part of C#, as you can see here. So you can create one from an int that counts from the beginning, or with a prefix, this caret operator that counts from the end. So if you index has become a data type, it's a new type, index I1 equals 3, that is number 3 from the beginning, and index I2 equals caret, this symbol caret 4 is number 4 from end. So if you have got an array of integer a which has got elements from 0, 1, 2, 3 up to 9, and then if you put a console.write line within string interpolation $a of I1 comma a of I2, then it will produce 3 and 6. Why 3? Because I1 is equal to 3 and a of I2 is the number 4 from end. So 1, 2, 3, 4. So 3 and 6, 3 comma 6. Right. The team have also introduced a range type which consists of two index values, one from the start and one from the end. The range can be written with the x dot dot y range expression. You can then index with the range in order to produce a slice, just like var slice equals on that array integer array a I1 dot dot I2. It will produce 3, 4, 5 because I1 is that is the number 3 from the beginning. So the number 3 from the beginning means index is fourth index, the fourth member, that is 3, and up to I2, that is fourth from the end. So 1, 2, 3, 4, that is this one, this position 3, 4. So this range will include all the elements 3, 4, 5. These features are part of C#8. Async streams. So this is very important actually addition. With the increase of streaming of data inputs through an IoT Internet of Things box, and thereby the need to retrieve the data signals as and when it comes in, it makes sense for C# to make way for iterating over an enumerable asynchronously. This is done in C#8 using the yield keyword to get the data as it comes in, but we need to ensure that the process doesn't block CPU while we wait. In comes iAsync enumerable to the scene. So Microsoft introduces iAsync enumerability, which is exactly what you would expect, an asynchronous version of excuse me, this pattern using yield return is the recommended model for producing async streams. So async enumerable of int. So there is a method get big results async which returns asynchronously async enumerable int, and it awaits on a for each, await for each var result in get results async. If result is greater than 20, yield return result. So this is a yield returns was used from a long time back. Yield return means as the result is yielded, as the result comes in streaming, it will be returning the result. So yield and then return. However, this code is not very good. This is incomplete. This doesn't define the body of the get results async. So you can see that get result async, it's not defined this method, and also this get big results async, this is straight from the Microsoft documentation, and they have not shown any implementation detail for this method, as well as how to use this, call this outside method. All right. So I have implemented in code the above two aspects of the code snippet. The first one is that it doesn't define this body, and it neither shows how to consume the big results async method in the Microsoft reference. So I will show it in another video very soon. Please watch on. Now next is serial port API is now supported on Linux. The serial port may seem like an old peripheral that you have not seen on a machine in years. It's not a commonly used or available port on laptops and desktops, but it's critical for Internet of Things solutions. Microsoft now have support for serial ports on Linux. Up until now, support was limited to Windows. So you have got several IoT, the hardware that uses these type of pins, GPIO, PWM, SPI, and I2C. So they have got APIs from .NET Core. So IoT devices expose much more than serial ports. They typically expose multiple kinds of pins that can be programmatically used to read sensors, drive, LED, LCD, E-Link displays, and communicate with our devices. So .NET Core now has APIs for all of these types, okay, pin types. These APIs are available via system.device.gpio NuGet package. So there is a NuGet package, and it will be supported for .NET Core 2.1 and later releases. Now cryptography. Microsoft added support for AES GCM and AES CCM ciphers implemented via system.security.cryptography.aes GCM and system.security.cryptography.aes CCM. These algorithms are both authenticated encryption with associated data AEAD algorithms and the first authenticated encryption algorithms added to .NET Core. Now, cryptography will not be interesting to all of you developers, those are students, but those who are in the cryptography area, they will find it interesting. So cryptographic key import export. .NET Core 3 Preview 1 now supports the import and export of asymmetric public and private keys from standard formats without needing to use an X509 certificate. Now more BCL improvements, base class library, MS optimized span T, memory T, and related types that were introduced in .NET Core 2.1. Common operations such as span construction, slicing, parsing, and formatting now perform better. Additionally, types like string have seen under the cover improvements to make them more efficient when used as keys with dictionary T key, T value, and other collections. No code changes are required to enjoy these improvements. The following improvements are also new in .NET Core 3 Preview 1. So these are some of the improvements. Threadpool.unsafe queue work item, unsafe.unbox, cancellation token.unregister. So just I have listed without explaining them. Okay, so if you are finding it interesting, you can go through looking in the Google for all of these, whatever interests you. Okay, so default implementation of interface members, that's another interesting thing. Today, once you publish an interface, it's game over. So you can't add members to it without breaking all the existing implementers of it, because what an interface is. Interface is just a blueprint. It contains some members, some method signatures only, no body. So all the methods need to be implemented in an implementing class. So once you publish an interface, you cannot add more members to it because it will break the existing implementers. Hold on. In C# 8, Microsoft lets you provide a body for an interface member. Thus, which was an unusual thing, which was not there so far. Thus, if somebody doesn't implement that member, perhaps because it wasn't there yet when they wrote the code, they will just get the default implementation instead. Interface iLogger, this is just a little bit code. So a class console logger is implementing iLogger interface. So you can see this void, this log of exception class is not getting implemented in the implementing console logger class, but it will get default implementation and it will compile. Okay. So assembly metadata reading with metadata load context. Microsoft have added the new metadata load context type that enables reading assembly metadata without affecting the caller's application domain, and assemblies are read as data, including assemblies built for different architectures and platforms than the current runtime environment. So metadata load context is available in the system.reflection.metadata-load-context package. There is a .NET Standard 2 package. Metadata load context APIs return assembly objects, enabling the use of familiar reflection APIs. Scenarios of metadata load context include design time features, build time tooling, and runtime light up features that need to inspect a set of assemblies as data and have all file locks and memory freed after inspection is performed. And platform support. So .NET Core 3 will be supported on the following operating system: Windows Client, Windows 7, 8.1, 10. I'm not sure about 1607 plus. So Windows Server 2012 R2 SP1 Service Package 1, Mac OS 1012 RHEL, and these DEBA and 9 plus SLES. So I don't understand.